Hello, in this video I will explain the properties of objects in the robot simulator CoppeliaSim or VREP. I am Leopoldo Armesto and this video is part of a tutorial about the use of CoppeliaSim for robotic courses that I normally teach at the Polytechnic University of Valencia. The aims of the presentation are basically to describe the main properties of objects in CoppeliaSim, understand the differences between a respondable and non-respondable objects, as well as between dynamic and static objects, to show some of the basic properties of shape and appearance of an object and understand visibility layers of objects, and also to understand special properties of an object that will affect the way in which the simulation is performed. So objects can be dynamic or static. A dynamic object is affected by forces such as gravity, collisions between objects, and other restrictions such as joint, as we will see. On the contrary, a static object can modify its position or orientation only if we modify it manually or if we do it by code, by programming. Okay, but they do not depend on these forces. Okay, so they basically allow us to implement purely kinematic simulations, which are more easy to understand. So, in addition to this, objects can also be reactive. Reactive is a property which is known in this simulator is known as respondable, and basically it implies that a reactive object can react against another object, also another reactive object, if there's a collision. So here I will explain the object interaction map. So if you want to get further information, you have to follow the link I show you below. So, so let's say that for dynamic properties we have four possible cases. So an object could be a static object or dynamic, but could be also at the same time respondable or non-respondable. And depending on the properties of these objects, they interact different on each of the cases. So for instance, when we have two static objects that are non-respondable, the objects won't move, they will be static, so they won't move at all. And since they are not collision at all, or even if they get into collision, they do not react because they are non-respondable. So also, we have the case in which the objects, both of objects are static, but one of them is respondable. In this case, because of the objects are static, they don't move, so they don't react. And there's another or third case in which one of the objects is dynamic. In this case, the dynamic object will move, let's say with the gravity falling down, okay? And if that object is non-respondable, means that whenever it enters into a collision with another object, it will not react. So if it's falling, for instance, imagine that you have a dynamic object but not reactive, just on top of another object, then once it's falling down and passes through, it will pass through the other object because it does not react. It does not generate a reaction force. And the case in which both objects will actually physically interact will be the case in which, for instance, the objects are respondable. It could happen, for instance, one of them is dynamic, the other one is static, but basically if the dynamic object is falling down and both of them are respondable, then they will react based on the principles of the third Newton's laws, action and reaction. And also objects have special properties, and these properties are very important in order to control the way we execute our simulation. Specifically, the most relevant properties are the collidable property, which means that if we activate this property, then an object with this property active will enter into a list of objects that can collide, which means that it will be used in order to detect possible collisions with other objects, but it does not imply that they will react. They are basically used for other calculation purposes like path planning in order to compute collision-free paths. Okay, so these algorithms or these modules will try to find or know which objects are collidable and which are not collidable, and only the collidable objects will be considered for their computation. Also, a detectable object will be detected by proximity sensors. So if we activate this property, means that proximity sensors such as ultrasonic, laser or infrared can detect the object and will provide a distance of that object to the robot or to the sensor indeed. Okay, so another property will be the renderable property, which means that these objects can be seen by vision sensors. So if you activate this property, then you have a camera in which you can do some processing, and only the objects with this property active will be actually rendered on that camera and then can be detected. And finally, the measurable property will be used for the minimum distance calculation module, which is useful in or convenient in certain cases, specifically to avoid collisions too. So also objects have some shape properties, especially related with the geometry, and we can modify, for instance, the scale of an object, so we can scale it and make it bigger or smaller, and also we can adjust the color and even to provide a texture to an object to modify its appearance. And finally, what we can do in the properties of an object is to control the visibility layers. The software has 16 visibility layers that allow us to show or hide objects during the simulation. So the first 8 layers are usually used to show, let's say, nice objects, which are usually more complex objects such as meshes or convex objects, and they are usually used by the graphic engine, which is in charge of displaying them in our simulation. And the following 8 layers are usually used to show simple objects, and they are part of our simulation, mostly affecting our physics engine. Usually we can here include pure objects or maybe convex objects too, and also joints. So these objects are usually hidden on our simulation, and this can be controlled using a global mask. So the global mask by default uses the first 8 layers, as you can see here, active, but we can invert that and we can see the objects that are on the other layers, so we can see what's behind the simulation. Okay, so we will see all these properties on the next video. Thank you very much.